I am going to take it from the aspect of the linear and one quadratic that have to lead to simultaneous equation. Not only that, we also talk about how it's being applied to other topics. So let's start by telling ourselves the foundation story behind quadratic equation. There are 4 major methods used in solving simultaneous equation. 1, we have factorization method. 2, completing the square method. 3, we have formula method. 4, we have graphical method. Now, as this class is concerned, we are only interested in one and one. That one is called completing the square method, which we need to also call formula method. I need to say this clearly, please. I've had people saying almighty formula. Please, that statement is wrong. There's nothing like almighty about this method. Because a time will come when we have negative roots, it can be solved. Then we have to resolve what we call complex number. So then what do you call it almighty? Almighty simply means it's solvable. That's why we say we have almighty God. But please don't call it almighty formula again. Just say formula method. So we'll start from completing the square method, which we take out what we call formula method. Factorization, that is from GSS class. And there's no way anybody can teach you factorization method rather than you be told the rules and regulations. Finish. After which, you have to use your number 6 to think of the factors before you can use what we call factorization method. And as WAEC is concerned, WAEC will not ask you any question. I stand to be corrected and solve this question using factorization method. I have never seen that in any past question. Rather, you will see it solved using completing the square method. Because that's a method that most students like to run away from. You don't need to think of any factor. You have to keep working. Follow the step-by-step method. So I'm not interested in what we call complete the square method under the quadratic equation. We start by saying it's always given to us in form of ax squared plus bx plus c equal to 0. This is a quadratic equation. Why? Maybe I should even ask, why do you call it quadratic? How do you know it's quadratic? The highest power of variable have to be 2. The highest power of a variable have to be 2 for it to be called quadratic. And at the end of quadratic equation, you must have 2 answers. Yes, sometimes you have one answer. This is not just one answer. It is called plus or minus that answer you have. A good example of when you have x squared equal to 9 and you say x equal to 3. This is wrong. You rather say x squared equal to 9, x equal to plus or minus root 9, x equal to plus or minus 3. So the answer is not 1. It's 2 answers there. So once you have 2, it's called quadratic. And as such, you must have 2 answers. This answer is 2. It's plus 3 or minus 3. Please take note of that. So let's start from the basic of quadratic. We want to use what? Completing the square method. It has step by step. There are like 5 or 6 steps. Once you can keep those steps in your number 6, I tell you, you are done with quadratic. There's nowhere quadratic can even threaten you at all. So let's start. The step 1, I'll be stating the step. You can write it down over there. I'll be stating it. Step 1 says that make the coefficient of s squared 1. The coefficient simply means, look at here, because I'm trying to take it from foundation so that you flow along. What is the meaning of coefficient? Coefficient of a particular item simply means what is attached to that system. As I stand here now, if anybody stand beside me here right now, that person is my coefficient. So coefficient of s squared makes it to be 1. Where is s squared? What is there before? A. Coefficient of s squared is a, but we want to have it as 1. So what do? We divide through by a. We divide through by a. So what do you have? X squared plus what? Bx over a plus c over a equal to 0. That's step 1. Step 2. Transfer the constant to the right-hand side. Where is constant? This is constant. Why do you call it constant? Because this is variable. It's attached to everything here. This is also variable. So there's no variable here at all. That's why it's called a constant. Transfer it to the right hand side. So what do you have? X squared plus bx plus over a equal to minus c over a. That's second step. Step 3, very, very important. Step 3 and step 4 is very, very important. Please take notes. Step 3 says half the coefficient of x and square it, half the coefficient of x square it, and add it to both sides. I will say that again so that in case you are writing. Half the coefficient of x, square it, and add it to both sides. What does that mean? Half, please mind my speech, is HALF, not HAVE. Half divided to 2. Half the coefficient of x. What is coefficient of x here? This is what is attached to the x. Half it, square it, then add it to both sides. So let's permutate together. B over A divided by 2. That's the meaning of half. Which means B over A times 1 over 2. Which means B over 2A. Square it. Add it to both sides. What are the sides? This side left, side right. So let's go. X squared plus bx over a plus b over 2a equal to right side plus b over 2a. Step 4 now. As I said earlier, step 3 and step 4 are very, very important. Step 4, please take notes. To complete the square, the left-hand side becomes x plus b over 2a square. I will go back again. To complete the square, the left-hand side, the whole story from here down here becomes this. Sorry, there's no magic there. Open the bracket here. You see that you have this. There's no magic. Then the question is, how do you know that that's what we're going to have? Very simple. Come to this, pick this one, pick this one. Both of them have square, square. Bring them together and put the square outside. The sign that is here will represent the sign that will separate them. So let's go. What do you have? X plus b over 2a square. Then what do you have? Minus c over a plus b over 2a. That's step 4. Let's go step 5. Step 5. Factorize the right-hand side and solve for x. Finish. Factorize the right-hand side and solve for x. Let's factorize the right-hand side. What do you have the right-hand side? See it here. Yeah, factorize. What do you have? Minus c over a plus b squared over 4a squared. That's it. Let's go. SCM here. 4a squared. A in this times this minus 4ac. This in this times this b squared. This one is still here. He said factorize the right hand side and solve for x. So we are trying to solve for x now. So we have x plus b over 2a square equal to what? B squared minus 4ac over 4a squared. Minus 4ac plus b squared is the same thing as b squared minus 4ac. So in factorizing the what? The right hand side to solve for x, we have this. When this one comes here, that is the square, it becomes square root, meaning that times 1 over 2 times 1 over 2. What do you have? Plus or minus b squared minus 4ac all over 4a squared. Square root of this denominator is 2a. That is 2a squared times 1 over 2 is this 2a. So the down one becomes 2a. Then we have what? X equal to, when this one comes here, becomes what? Minus b over 2a plus or minus b squared minus 4ac all over 2a. Finally, we can take the SCM between this and this, which is what? 2a. 2a and 2a, 1. 1 times minus b plus or minus 2a in this times this, same thing as this. You have b squared minus 4ac. If you look at it critically, this is what you students call almighty formula. And as I said earlier, there's nothing like almighty about it. Because if you have minus value inside this root, if you press the calculator, it will tell you signs error, which means that there's nothing almighty about it. Meanwhile, minus root can still be solved. According to complex number, when you find yourself in university, complex number, you will solve that. Minus 16 square root like this is solvable when you get to university. But as low level is concerned, you'll be seeing that what? Sign error. So if you are seeing sign error in there and you are calling it almighty formula, that means not almighty. Point I'm making here, don't call it almighty. Just say formula method. As I said earlier from the beginning, we have 4 methods. Factorization method, complete the square method, formula method, and graphical method. I say I'm more interested in what? Complete the square method, which will lead us to what? Formula method. That's what you just see now. Are you there? So let's cite a critical example to compare and contrast between this complete the square method and formula method. We are going to use the 2 methods to solve this question. We are going to use complete the square method and also the formula method. Let's start with complete the square method. What does it say? From beginning, we have steps, up to 5 steps. Let's follow those steps that we took earlier. It says, the first one says, make the coefficient of x squared to be 1. Coefficient of x squared here is 3. That means divide through by 3. What do you have? X squared minus 5 over 3x minus 7 over 3 equal to 0. What the second step says? It says transfer the constant to the right hand side. In this case, what are constants? These are constants because it has no x with it. It has no variable. So we have what? X squared minus 5 over 3x equal to 7 over 3. Third step. That was what I told you that step is very, very important. It says half the coefficient of x, square it, and add it to both sides. So let's go. What is the coefficient of x here? The coefficient of x is what? 5 over 3. Let's compute it. 5 over 3, half it. That gives us what? 5 over 3 times 1 over 2, which gives us what? 5 over 6. That's half of it. Square it. Then add it to both sides. So let's go. X squared minus 5x over 3 plus 5 over 6 equal to what? 7 over 3 plus 5 over 6. Step 4. Remember when I told you step 4? I said to complete the square, the left hand side becomes, I wrote something the other time. And I said there's no magic about it. How do you get it? Just come and pick this first one and this one. They have both square. The sign that is here will be the sign that will be separating them. So let's go. That means you have what now? X minus 5 over 6 squared. That's all. So let's come back here. 7 over 3 plus 25 over 36. There's no magic about it. Of course, the next step will tell you that what? Simplify the right hand side and solve for x. So I've started simplifying already. So let's go more to what? To the right hand side. Simplifying of it. So let's go. SCM here is 36. 3 in 36, 12. 12 times 7. 3 in 36. I can hear you. Are you not in the class? 3 in 12, 12. 3 in 36, 12. 12 times 12 times 7. 84 plus 36 in 36, 1. 1 times 25, 25. So let's go. X, 5 over 6, all square. 84 plus 25. That gives us 109 over 36. By the time we take the square out here, we have x minus 5 over 6 equal to plus or minus 109 over 36. Shall we? X equal to minus 5 over 6. By the time I bring this one in, plus or minus 109 over 6. How do we get 6? Square root of 36 is what? 6. So, this simply means x equal to 5 over 6 plus 109, 6, or 5 minus 109 over 6 over 6. Of course, that's why you have plus or minus. And from here, you can compute it and have your Final answer. That is using completing the square method. Let's now use the formula method that we derive. The formula that we got. That says x equal to minus b plus or minus b squared minus 4ac all over 2a. Now the question is what? 3x squared minus 5x minus 7 equal to 0. In comparing it together to the canonical form, which is called standard form, to the standard form of the quadratic equation, comparing them together, a equal to 3, b equal to minus 5, c equal to minus 7. So put this parameter into this formula. X equal to minus, what is b? Minus 5. Plus or minus b again, minus 5 squared. What is a? 3. What is c? Minus 7. All over 2a. Our a is what? 3. So let's open the bracket. This is ordinary 5. This is 25. Minus times minus plus. 4 times 3. 12. 12 times 7. 84. All over 6. Finally, x equal to 5 plus or minus 109 over 6. Plus or minus, which means x equal to 5 plus 109 over 6 or 5 minus 109 over 6. Look at it critically. You can see the answer we have here is the same answer that we have here. That means both methods are the same. But why could not ask you to use this method? Because it's straightforward. This is what they asked to use. I cite a good example. 2016. This why question. 2016, good and fine. 2016, May, June, question 7a. Please, if you have the question, check it here. It says, using the completing the square method, solve correct to 2 decimal places. Can you see? So let's check the question. This one, just to confirm to us that the 2 methods are equal. But you should get used to the 2. Why? Because why may ask you the specific one. If you are only used to this one and you don't know this, that's another problem. So let's solve this fast. It says, yeah, let's go. It says x minus 2 all over 4 equal to x plus 2 all over 2x using complete the square method. How do we solve this one? Using the complete the square method. Let's go. Without wasting our time, this is equal sign. You have to cross multiply. 2x, x minus 2, 4x plus 2. Let's open brackets. 2x squared minus 4x plus 8. Now let's go. 2x squared minus 4x minus 8 equal to 0. 2x squared minus 8x minus 8 equal to 0. Yes, we have reached what we call quadratic equation. But the best thing you can do from here, because you can see that 2 is common, divide 2 by 2 so that I can reduce the power. What do you have? 2x squared minus 4 equal to 0. Now, we have to use completing the square. So let's start with completing the square method. First one says that make coefficient of x squared to be 1. Automatically, it's already in 1 now. It's already in 1. Transfer the constant to the right-hand side. What do you have? X squared minus 4x equal to 4. What's the next step? The coefficient of x, square it, and add it to both sides. What is coefficient of x? 4. Half it. That gives us 2. Square it. They add it to both sides. Let's go. X squared minus 4x plus 2 equal to 4 plus 2. Are we together? Now, to complete the square, you pick this and this as I told you earlier. But the sign that is here will be sign that will be separating them, which is what? X minus 2 equal to what? 4 plus 4. Of course, I've started applying the step 5 that says simplify the right hand side and solve for x, which is what now? 8. We have what? X minus 2 equal to plus or minus square root 8. X equal to 2. When this one comes here, become plus. Plus or minus root 8. I think that's all. Root 8 will give us what? 2 point something. It's not to 3. Or, preferably, you can leave in a short form. That's 2 root 2. Finally, what do you have? We have 2. We have 2. X equal to 2 plus 2 root 2. Or 2 minus 2 root 2. That's all. That's the answer. 2016, question 7A. Let's take another one for another past question again. For us to know how to apply this quadratic equation. Before we now move to one linear, one simultaneous, one linear, one quadratic under simultaneous equation. Let's see more example. Solve the quadratic equation. Giving your answer in form of a plus b root 3, where a and b are constants. This is another application. That's why I shared it earlier. That's why it's called quadratic. Why could not ask you direct question? They will put in apply. So this is another example. It says, solve the quadratic. 1 plus 1 minus root 3 x squared plus x plus 1 plus root 3 equal to 0. Leaving your answer in form of a plus b root 3, where a and b are constant. Can you see that? That's another application. It's just quadratic that is very simple. But it's another application. If you don't know that the standard form of quadratic is always ax squared plus bx plus c equal to 0. Now, you notice this. We are not asked to use a specific method. That means you are at liberty to use any method that pleases you. But let me tell you the truth. There's only one method that is very easy to use here, which is called formula method. Or I call it formula method. I said it earlier, I don't call it my formula. Look at it. It means A is everything here. B is 1 here, 1. While C is everything here. So we apply formula method that says x equal to minus b plus or minus b squared minus 4ac all over 2a. So let's go, everybody. Let's go. Are you there? B. What's our b? Our b is 1. Thank you. And our b again is what? 1. Minus 4. What is our a? 1 minus root 3. What is our c? 1 plus root 3. This is just an applied question. Checking you that, do you know the foundation? 2. What is our a? 1 minus root 3. Check it. If I show you the answer now, you'll be surprised that this is just an application. Check it out. You're going to see something very funny now. Let's go. X equal to minus 1 plus or minus. This is still 1. Minus 4. Look at this statement. Open your eyes. Look at this statement. 1 minus root 3. 1 plus 2 root 3. These two statements, it means something in mathematics. It is called difference of 2 square. That is what they are checking from you. It's called what? Difference of 2 square. You don't believe that? Let's check it. Let's check it one after the other. Let's open the bracket first. 1 times 1 is 1. 1 times plus 3 plus root 3. Well, that's plus root 3 minus root 3 times 1 minus root 3. Minus root 3 times plus root 3 plus minus 3 square. Still under roots. I'll come back to your level to say that. Let me come to your level. Root 3 times root 3 is ordinary 3. That's solid. So writing this one here is for you to know what that, so that you don't get confused. Root square here will cancel this root. Let's go. Under 2 minus 2 root 3. Fast. Let's complete it. Minus 1 plus or minus 1. 4 plus 3 minus 3. Cancel. And this one automatically becomes what? Ordinary 3. So we have 1 minus 3. That gives us what? Minus 2. Over 2. Without wasting our time. Minus 1 plus or minus. This is what? 8. Isn't it? 1 plus 8. This is 9, isn't it? That 9 give us what? Root 3. Root 9 is what? 3. So you have 2 minus 2 root 3. Let's go. What do you have? X equal to minus 1 plus 3. Is anybody here? All over 2 minus 2 root 3. This gives us what? 2 all over 2 minus 2 root 3. Of course, you can leave your answer in this form. But the question says leave your answer in form of a plus b root 3, which means that we have to rationalize. Can you see? We are dealing with quadratic and we are seeing solved again. We have to rationalize. What do you mean by that? 2 over 2 minus 2 over root 3 times 2 plus 2 root 3 all over 2 plus 2 root 3. So we have to rationalize. In rationalizing, let's see, what do you have? This time this. We have 4 plus 4 root 3 all over this time this. 4. This time this. 4 root 3. This time this. Minus 4 root 3. This time this. Minus 4 times 3. Finally, we have what? 4 plus 4 root 3 all over this cancel this plus 4 minus 4. 4 minus 12. Finally, what do you have? 4 plus 4 root 3 all over minus 8. Mathematically speaking, we can finally write as x equal to 4 over 8 minus 8 plus 4 over minus 8 root 3. Finally, what do you have? Minus 1 over 2 minus 1 over 2 root 3. If you are asked, you asked to leave it as a plus b root 3. If you ask a is what now? Minus 1 over 2. B is what? Minus 1 over 2. That's all. It's an application. Yes, you can say quadratic is very, very simple. Very simple. But a lot of application question under quadratic, like this one you see now, is checking solved inside quadratic. And now, if you don't know the whole 4 methods, you will know the one that is easy to solve this type of question. So let's see another applied question. So another one is this. It says, and I quote, if z equal to 2 plus root 3, find the integers a and b such that a z squared plus b z equal to minus 1 plus root 3. The interest we have here is to show you that you can see z squared. That's to show that you have to lead to quadratic. So let's take one after the other. In this case, we are giving z, which is our variable, as what? 2 plus root 2, root 3 rather. A, open bracket, 2 plus root 3, all square, plus b, against what? 2 plus root 3, equal to 1 plus root 3. We are interested to find a and b. But this square shows us that what it have to be related to what? Quadratic. So let's go. Let's open the bracket. A, open the bracket. What do you have? 4 plus 4 root 3. Ordinary 3. Root 3 square is 3. Plus b, 2b plus b root 3 equal to 1 plus root 3. Yeah, let's bring this together. This and this, that's 7 times a, 7a. Against this, plus 4a root 3 plus 2b plus b root 3 equal to 1 plus root 3. If you look at it critically, you can see that root 3, why this one does not have roots? Let's see. 7a plus 2b, 4a root 3, b root 3 equal to 1 plus root 3. You have bring them together. This should be equal to this. That is 7a plus 2b should be equal to 1. Why the root 3 should be equal to each other? That is 4a root 3 plus b root 3 equal to root 3. If you look at it critically, what does it form? It has formed what? Simultaneous equation. Now, look at equation 2. Root 3 is common. You can put root 3 outside and have 4a plus b root 3. This cancels this. Finally, what do you have? 4a plus b equal to 1. Again, 7a plus 2b equal to 1. Equation 1, equation 2. So let's solve them simultaneously. Let's bring them together. This is our equation 1. 7a plus 2b equal to 1. 4a plus b equal to 1. For us to solve it conveniently, using elimination method, we can say this times 1, this times 2. So that this and this can balance. As such, you have 7a plus 2b equal to 1. Oh, but this one, 8a plus 2b equal to 2. We can say equation 1, 2 minus 1. 8 minus 7, 8. 2 minus 2, 0. 2 minus 1, 1. We have gotten A, finished. So what else? We need to get B. I would prefer to use equation 2. Why? Because the B here has coefficient of 1. Therefore, we have what? 4A plus B equal to 1. B equal to 1 minus 4. B equal to minus 3. Very simple. Quadratic lead to simultaneous, lead to comparison. A equal to 1, B equal to minus 3. I hope you understand. Thank you.